Good morning. This is your Stats Sensei, Mr. Spensei, and we're working on part 2 of that FRQ review. Please remember your FRQ test will be one long scenario with about 9 prompts. And hopefully this will be a really great review. I know it takes some time. You may want to put it on a faster speed because I know I talk slowly sometimes. So we're continuing with the same prompt that we had before, but I'm going to reread it. So a company that manufactures smartphone developed a new smartphone that has a longer life than that of a traditional battery. In the date of purchase of a smartphone, the distribution of the lifespan of the new battery is approximately normal. Love that. With a mean of 30 months and a standard deviation of 8 months. For the price of $50, the company offers a 2-year warranty on the new battery for the customer who purchased a smartphone. The warranty guarantees that the smartphone will be replaced at no cost to the customer if the battery is no longer working within 24 months from the date of purchase. All right, we've done part B a couple times, but because it ties directly into this next part, I'm going to rework it again. And so this is going back. So if you want to skip ahead till we start part H, that's fine. So part B, one customer who purchases the warranty is selected at random. What's the probability the customer selected will require replacement within 24 months? All right, so we want the probability that X is less than or equal to 24 months. Have to have that. Our mean is 30. We have to have this graph. This is 24. We're looking for this. This goes to negative infinity. So I need a probability that Z is less than or equal to 24 minus 30 over 8. Now, we're ultimately going to need a norm CDF, but I have to calculate the Z-score. So stat test, Z-test. And my mean is 30, my standard deviation is 8, my X is 24. I was talking about a sample size 1. Press enter, calculate. So I end up with the probability that Z is less than or equal to negative 0.75 equals 0.2266. Now, we have to show that this is a norm CDF. And by the way, I know it's a norm CDF because they asked for probability. If they asked for probability, it's a norm CDF. So in this case, norm CDF. So if I go to the calculator to remind myself what's in norm CDF, oops, catalog, second bar is norm CDF. It says, oh, it wants our lower, where our lower, based on our graph, is negative infinity. And we remember we use negative 9,99. My upper, in this case, is 24. It asks for my mean, which happens to be 30. And it asks for my standard deviation, which happens to be 8. And once again, I get 0.22. All right, we're going to be using that several times. So I'm going to write that down because B equals 0.2266. We'll be using that for several parts. So using your answer in part B, oh, that's what we just said, 0.2266. What is the probability the first customer is to replace their battery is the 7th customer? All right, so the word first indicates to me that I'm probably working with a geometric. Not only that, I'm looking specifically probability that X equals 7. All right, so that's what we're looking for. Now, geometrics, I need to have a number line, and the number line can start at 1. So the geometric starts at 1. The binomial starts at 0. The geometric starts at 1. And when I circle, I'm only looking for the 7th value. Since I'm only looking for the 7th, this tells our singular value. Since I'm looking for a singular value, this tells me I'm working with a PDF. The word first tells me I'm working with a geometric. So this is a geomet. It happens to be a PDF. Now, I don't remember everything in the calculator, and you don't have to either. We can just go back and go, all right, I know it's in there, geometric PDF, and it says, oh, it wants the p-value. What's the p-value? The p-value came from part B, which is 0.2266. It's also asking for our x value, and our x value happened to be 7. And so our answer is going to be 0.0484. And I'll come back to that in just a moment. I also need to show my math work. All right, my math work is I can make 7 blanks or I can make 2. I'm going to make 2. This is 0.2266, and that's my success. And my success is always going to be the first power with the geometric every single time. All right, this is going to be 1 minus that. And it's going to be 7 minus 1, which is 6. All right, and what did that equal? 0.0484. And the order of these doesn't matter so much as we just need to have it. So I need this, I need this, I need this, I need that, and I need that. All right, that's what you have to have there. All right, the next question. Using your answer in part B, what was that? 0.2266. What is the probability the first customer, oh, there's that keyword first. First customer when we're working with geometric, to have to replace their battery. Oh, we don't need this. That's not going to be part of yours. Is among the first 7 customers. So what's probably the first customer to have to replace their battery is among the first 7 customers. All right, so here we go. We need our probability statement. Well, our probability is x is less than or equal to 7. And we should have our number line. Remember, geometrics always start at 1. And they go up to infinity. And it says among the first 7. So that means it could be the first, second, third, fourth, etc. So I'm circling multiple values. The fact that I'm circling multiple values tells me this is going to be a geometric CDF. All right. So it's going to be a geometric CDF. Well, remember, a CDF is just the sum of the PDF. So it's going to be the sum of 1 plus the sum of 2 plus the sum of 3, etc. So in this case, I have multiple values. So I'm going to need to, well, we'll go ahead and do the geometric CDF first because this is easy. Geomet CDF. So I'm going to jump into my calculator, see what it asks for. Geometric CDF. And I just went second bars to get there. P, okay. That came from part B, 0.2266. P equals 0.2266. X value. All right. Our X value is the highest thing we want, which in this case is 7, excuse me. And we get 0.8344. I'll come back to that in just a moment. So now I'm going to show my math work. All right, so to do the math, we're going to do the lowest and the highest. So I need 2 blanks for the lowest. This is going to be 0.2266, because that's my success. It's always raised to the first power. This is going to be 1 minus that, 1 minus 0.2266. 1 minus 1 is 0. Now, plus, dot, 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 plus. I need 2 more blanks. This is going to be right here, 0.2266. That one will always be to the first power, just like it is here. And this is going to be 1 minus that. So 1 minus 0.2266. And 7 minus 1 is 6. Notice 0 and 1 add to the first one, 6 and 1 add to the second. All right. So what does it equal? it equals 0.8344. All right, so what do I have to have? I have to have this, I have to have the number line, I have to have this statement, I have to have my math work, and I have to have this. So the orders can change a bit, but those are the things that I have to have in order to get full credit for that. All right? All right, so using your answer in part B, what is the probability that 2 out of 7 customers have to replace their batteries? Notice, guess what? We're back to part B, so we're back to the 0.2266. But this time, they're not asking about the first. They actually give me a group size. They gave me a group size of 7, all right? And so because they gave me a group size, this tells me it's like, oh, we have a certain number, we have a sample size. We're talking about using a binomial, all right? So what is the probability that 2 out of 7 have to replace? We want the probability that x equals 2. And binomials always start at 0 when we do our number line, and we have to have it. So there's 2. And we have a singular value. All right, so that tells me I'm working with the binomial PDF because it's a singular value. So binom PDF, second bars. Scroll down to binomial PDF. The very first thing it asks for is trials. Well, in this case, trials is our sample size of 7. Our P came from part B, which is 0.2266. And our X, in this case, is just the value 2. All right, I'll come back to that in just a moment. But now I need to show my math. Well, in this case, 7, choose 2, 0.2266, and to the second power. So whatever's here is what's going there. 1 minus 0.2266. 7 minus 2 is 5. And that equals 0.2983. All right, I need credit. What do I have to show? I have to show this. I have to show the number line. I have to show this. I have to show this. I have to show that. All right, so that takes care of J. Moving on to K. Using your answer in part B, what's the probability that at least 2 out of 7 customers have to replace their batteries? All right, I'm going to run out of room if I go sideways. Oh, and by the way, it says part B. What was part B? B equals 0.2266. All right, so first off, at least tells me I'm going to be working with a 1 minus situation. 2 out of 7. Oh, 7. I have 7 customers. That means I have a specific sample size. That lets me know I'm working with a binomial. So we want the probability. We need our probability statement. That's the probability that X, I'm going to start over before I get really fouled up, because when I start making mistakes, I tend to make a lot of them. So I'm going to start over. So the probability that 2 is less than or equal to X is less than or equal to 7. By the way, if you get a little bit confused on that, we're going to make our number line, and our number line for binomial always starts at 0. So 0, 1, 2, 3, 4, 5, 6, 7. Those are the values I wanted. All right. And here's how I could go, oh, I circled 2, so I must want 2, so I need the line underneath. I want 7, so I need the line underneath. All right. So we have our statement here. We know this is an at least situation. So 1 minus the binomial. We have multiple value circles, so it's a CDF. Anytime we're working within an at least, it's a CDF. So I'm going to go to the calculator. 1 minus second vars, second vars, binomial CDF. It asks for trials. Well, trials is just my sample size. So trials, in this case, it's 7. P, well, we know our P because we keep using the same P is 0.266. Then we have to be really, really careful with this. All right, we have to subtract what we don't want. Well, I want 7, I want 6, I want 5, I want 4, I want 3, I want 2. So I'm not going to subtract any of those. The highest thing I don't want is 1. So that's what I'm going to subtract. So that's what's going there. All right. So 0.226. X value is 1. Let me 1 minus second vars. Told you once I start making mistakes, I make a lot of them. There we go, 0.4950. Come back to that in just a second. Because now I need to show my math work. All right, there's a couple of different ways to do this math work. Remember, the binomial is just the sum of the PDFs. Or excuse me, a CDF is just the sum of the PDFs. So I can do the PDF of 2 plus the PDF of 3. So I can show all of those. So I can do a 1 minus situation, or I can do the sum of those. I'm going to choose to do the sum of those. In this case, the sum of those would be 7, choose 2, 0.2266. That value goes there. This is going to be 1 minus that. 7 minus 2 is 5. Plus dot plus 7 choose 7.2266 to the 7th power. 1 minus 0.2266. 7 minus 7 is 0. All right. So that's one way to have done it. Another way that, so you could have shown it this way, and point equals 0.4950. All right, that's a good way to have shown it. There's another way to have done it, which would have been having 0 and 1, and you'd have to show both of them. So either way is acceptable. Things I have to see, I have to have this, I have to have this, I have to have this, I have to have that, and I have to have that in order to receive credit. All right, next question. Not going to do that one. And this one takes up a lot of space. It's a whole lot of fun. Okay, I'm lying about it being fun. As a result of this problem, I got to remake this video. And I need a full sheet of paper. Hopefully I have one. Here we go. Full sheet of paper. Given that a battery has lasted 40 months, what's the probability that it lasts less than 5? I don't want less. I want last more than 43. All right. Given that a battery has lasted 40 months, what's the probability it lasts more than 43? So first off, anytime we have a given problem, you know you're going to have something in the denominator. So we have a lot of work to do on this. So this is an intersection over given. And by the way, there will be one on the test like this. All right, intersection over given. So what are we looking at? Well, the denominator, given that it's lasted 40 months. All right, so probability that X is greater than or equal to 40. And what's the probability to last more than 43? So probability that X is greater than or equal to 43, right? So that's what we're looking at. Well, that means I need a graph. So this is a little bit weird, but I'm going to have a graph over a graph. Now they told me the underlying distribution is normal. We still remember that. This is 30. So that's my mean. My X is 40. We go up to positive infinity. For the numerator, mean 30. But now we're looking at 43 up to positive infinity. All right. So I'm going to need my z statements after that. So that's the probability that z is greater than or equal to 43 minus 40, or 30, excuse me, over 8 is the probability that z is greater than or equal to 40 minus 30 over 8. So I'm going to need a couple z-scores. Stat test, z-test. I'm going to do the numerator first, 43. So the probability that z is greater than 1.65. And that probability is 0.0520. Then I have to come back and do this one, stat test, z-test. This time it's 40 for the denominator. Probability z is greater than 1.25. Equals 0.1056. So 0.0520 divided by 0.1056. Yeah, 0.0520 divided by 0.1056 equals 0.4924. All right, still have to do my norm CDF statements. For the bottom, norm CDF. What's my lower? My lower happens to be 40. My upper is positive infinity. My mean is 30. My standard deviation is 8. My upper, norm, CDF. My lower is 43. My upper is infinity. My mean is 30. My standard deviation is 8. So second bars, norm, CDF, lower. We'll do the bottom one first. 40. Oops. 40. Upper 9.99. Mean 30. Standard deviation 8. 1.056. Hey, that's exactly what we got. 0.1056. Do the upper. Second bars, norm, CDF. 43. Because we just changed our lower. Everything else is the same. We get 0.5208. for 0.0520. And when we divide those out, of course, we're going to get the same answer. All right, so what do I have to see? We have to see this. We have to see that. We have to see this. We have to see this. And we have to see this. And it doesn't matter. I need to see one of these. I don't have to see both. I need to see one of these. So one of these and one of these. So a whole lot of work on that one. And I think I skipped a problem. So I'm going to come back and hit the problem that I skipped. So first off, this has an error. Yours hopefully will be corrected. It says, what is the probability that a group of 9 batteries have an average life of at least 3? So we're talking about average. All right, that's important. Because we're talking about the average, we're talking about the central limit theorem. All right, well, central limit theorem only applies if our sample size is greater than 30. Well, this is only 9, so we have a problem. But they told us up here the underlying distribution is normal. If the underlying distribution is normal, we're good to go. We can still use it. So here we go. Part I. Sorry, it's not, but it is what it is. So what's the probability a group of 9 have an average life of at least 3 5s? Probability that X is greater than or equal to 35, except it's not X. It's the average. Make sure you have a bar over that. The probability of X bar, because we will count off if you don't. All right, it's a big deal. So it's a big deal for normal. It's a big deal for college board. So make sure you have that. So our normal, we still have a mean of 30. Now we're looking for X bar, and our X bar is 35, and we're going to positive infinity. So we're working with Z equals X bar minus mu, standard deviation divided by the square root of n. You don't have to show that, but I thought it might be helpful when we go to plug in so you knew where I was getting things from. So the probability that Z is greater than 35 minus 30 over 8 divided by the square root of 9. All right, so I'm going to go to stat test Z test. Stat test Z test. Mean of 38, standard deviation of 35. Standard deviation of 8, X bar of 35, sample size of 9. We ended up needing a greater than this time. That's the way we shaded. So we have the probability that Z is greater than or equal to 1.875 equals 0.0303. Now, we always have to show our norm CDF. So our norm CDF, we need to be careful on this. Norm CDF. Our lower, oh, well, we know our lower is 35. That's easy. We know our upper is infinity, positive. Our mean is 30. Here's where we have to be careful. We're not working with the standard deviation. We're working with the standard deviation of X bar, which is 8 divided by square root of 9. All right. And if I were to run that through the calculator, I'd do this. Second vars, normal, CDF. Lower bound, 35. Upper bound, 9.99. Mean of 30. Standard deviation, 8 divided by 9, the square root of 9. So 9 to the half power. And there's the same value that we previously got, 0.03039. Now, what do we have to show? Well, we have to show everything I have here. We have to have this. We have to have this. That is not necessary. This is, and that is. All right. Hope this was really helpful. I think this is a good video. I'm sorry I went out of order, and look forward to seeing you next one. And good luck on your test. You guys got this.